So we'll get the obvious question out of the way up front. Yes, I did dress to match my slide deck. So that was an intentional choice. So tonight, I want to go through and start. Well, yeah, I didn't even need a green screen. It would have been slightly problematic. So tonight, I want to go through and start off with a little bit of a magic trick. So let's imagine that this rubber band here is our software, right? And naturally, we're going to go through and have this rubber band wrap around the first two fingers there. And just because of building, we're going to obviously wrap RFC 742. Now, for those of you who don't have your RFCs memorized, that would be the finger protocol, which should be pretty obvious at this point going forward. And then what probably comes through and happens is somebody like Mark will come along and say, well, you've done a good job here, but let's add in a few more requirements. And we'll just twist that on there and twist that on there. And that's all nice and working well there. And then we go through and we start building and we finally get our replacement going through. And then we get to our next release, and sure enough, Mark comes through and says, you know what, you've done a great job. This is perfect, but we're going a slightly different direction. We want it over here now. You know, the ring finger is great, index is where it's at. And we start realizing that we've got this problem. Hindsight's 2020, we could have gone through and done a better job architecting our code if we had known that this was going to be a requirement coming through, but it wasn't. And so now we realize that, okay, we've got to go do a bunch of work. We could back up, try it all over again, start over, but what if there were a shortcut? The thing with magic tricks, though, is once you know that they're there, you start looking for them. And then once you start knowing that they're there and looking for them, whoop, thank you, you start understanding how they're actually working. And so tonight, what I want to show you is code that may come across a little bit like a magic trick. But at the end of it, I'm hoping we come away with a little bit of understanding of how it's actually working. With that said, the problem with magical code is very easy to get into bad code land. A term you're going to hear me use a lot is WAT. I threw the definition up there. For those of you who aren't familiar with it, it is the only appropriate reaction to the code that I'm going to show you tonight. Normally, we try to show best practices, how things should work, the proper ways to do things. Please, none of the code you're going to see here tonight used for anything other than to maybe feel good about yourself at the end of the day. That is about the only useful purpose that it has. I do want to call out, if you guys haven't seen it, Gary Bernhardt has a wonderful video all about WAT on destroyallsoftware.com. It is very much worth the 5 minutes to watch that. It is absolute gold. So just to set some ground rules for how this code is going to work today. So there will be no preview features. Everything in here is going to be C#9, .NET 5, everything GA, what you can do, go out there and do today. There's going to be no reflection, no source generation, no IL manipulation, and no funky character sets or manipulating in that way. So what you see is going to be what is going to run. With that said, even with those rules, I'm pretty confident I can do quite a bit to make C# behave in very non-intuitive ways. So just to kind of keep that level set in mind, let's go ahead and dive in. So is that reasonable font? Somebody in the back, thumbs up. I'm getting head nods, so I'm going to go with it. So I've written a very simple application here. 14 lines. I mean, how bad could a 14-line application be, right? We can take a look at the CS proj, standard exe, .NET 5, nothing fancy going on there, right? We can kind of take a look at this. Proof is in the pudding, right? .NET build, and no, I do not wish to install stuff. Go away, VS Code, right? Compiles, that's wonderful, because if it didn't, that would be kind of a horrible example. We can run it. And we can kind of start to see the program work, right? It starts off, imports the system namespace, does a little output, asks me for my name. Simple enough. Okay, I will be Kevin today. You can enter your own name, right? So immediately, the program has a small identity crisis and is convinced that I am now Bob, which is okay, but not quite what I had hoped for. Close enough. Wants to know my birthday. And, you know, it's a simple line, right? Line of output, read a line of input. Somebody earlier asked me if I was born yesterday, so I figured that's a good enough birthday to work with. So we'll go with that. And then you'll note, once again, small identity crisis. Writes another line of output, is convinced that my name is Joe, that my birthday was on the Latin month Lune. I'm 34 years old, coffee cup in 4 months, and then weird emoji face days old, which I think is pretty obvious from this code that we've written here, exactly what we would expect the output to be. So there's a bit of a magic trick going on here, obviously, because I'm guessing if you had been asked, what is this program going to do, that is probably not your go-to answer. So the first question is going to be then, how did we get all of this in here? Now, for those of you, some of you might actually be familiar with some of these magic tricks. I've been putting this material together for over a year, just kind of gathering weird things like this that you can get away with. If you're familiar with the magic trick that is being performed, I would invite you, sit back, watch the people around you. The faces are priceless. It's going to be awesome. For those of you online, since you can't do faces, the little laughy emoji, this is the appropriate time to use it. Okay? So first thing that we're going to note is that our code is there's clearly more code being run than what we see here. So I'm going to do something. You'll note that I am down in C:dev calamities. 2 calamities, because 2 was better than 1. But we're going to go up a directory. You know, so still have my program CS, but nested 1 level higher, you'll know I have a directory build props file. So for those of you unfamiliar with it, there are a couple magical files that you can use inside of .NET programs. Directory build props, there's targets, and then ironically, the one for the source control stuff, the editor config. All of those files get picked up by your build system by walking up your directory tree. They don't stop. They have no concept of where your repository root is. You could put one of these at C:. Don't do it unless you want your coworkers to really, really hate you. But you can now add things in. The format of these files is the same format that you see inside of your CSproj file. There's nothing overly fancy on it. You can use it to set build properties. You can use it to include files. And as you can see in this case, I decided to include everything underneath the bad stuff directory. And as the name implies, that's where the fun happens, right? So let's go ahead and take a quick look. Oh, actually, real quick, before I get too carried away. In this 14-line program, there are exactly 3 lines of reasonable code in here. In case you can't find them, they're lines 2, 5, and 8. Incidentally, there are also the bug-free lines in this program. I'm pretty sure every single other line of code I have done something horrendous to somewhere along the path. So I did my best to cram as much WAT into as few lines as possible as I could come up with. So let's go start at the top. So one of the things that you will note is on line 11 here. For those people who may not be on latest versions of C#, there was a concept introduced around the time value tuple came into play called object deconstruction, where, and most of the time when you're using a value tuple, it gives you a nice easy way to go from some instance into its constituent parts. And normally with a value tuple, you would take a value tuple and break it apart into its individual members, which is great. That's exactly what you want. In this case, we are taking a time span and breaking it apart into its individual parts. Now, I showed this to a friend of mine, and his first comment was, I didn't know time span had a deconstruct method. And my answer was, it doesn't. And then I got a facepalm emoji and then a whole bunch of more scrutiny on my code. The other thing to note is time span doesn't actually have anything past days. Time span, if you look at the members on it, goes up from, milliseconds, seconds, all the way up through days, but it doesn't have months or years. So what exactly is going on? So we'll take a look. I numbered them for simplicity. So you'll note here, I have written my own deconstruct method. And the wonderful part about the feature that Microsoft implemented when they added this concept of deconstruction is you don't have to implement it on the actual type. It can be implemented with extension methods. So you can add deconstruct functionality to any type you like. And it's the same, so extension methods, when they were added, there's always the built-in rule of if the actual member defines that, the one on the member gets to win over the extension methods. You can't override something that somebody else would have there. But you can go through and give yourself deconstruction. And just to be fun, I went through and I also figured, well, if I'm going to have a WADI thing, I might as well continue on and implement it as bad as I can possibly come up with. So you'll note here that the days is just a random value. The months is a value between 1 and 12. And then the years, we went for something somewhat sane, right? We're just going to assume leap years aren't a thing, divide by 365. Close enough, right? But there's one thing I want to call out here. So if I dive in here, get me back in. Would you go away? I need an option to make that go away. So if I .NET run again, right? Oh, except for you have to spell .NET correctly. That's important. And so we'll go Kevin yesterday. You'll note something, and I realize I closed the other terminal down, but the birthday that it lists there, those numbers should look remarkably familiar. Just keep that in mind. That's going to be important a little bit later. Let's go back and take a look. So how did we end up in this situation? We tried to get a time span out, date time parse, datetime.now minus day. Those seem like reasonably okay things to have. So how would we end up getting some pass in the string yesterday? So if we take a look, though, up at line 7, there's a small problem here. Most importantly, there's something a little different that I would not normally recommend. So in Teletech, we have a large coding guidelines repository if people are interested in checking it out. And one of the specific guidelines that's in there is when there is a keyword available, use it over the BCL type. In this case, BCL base class library, capital string. And the reason for such a requirement is because someone like me could do this and declare my own string class. So I'm no longer getting system string in my application. I'm getting my own string class, which is awesome because I now have strings. Something else that may not have been immediately apparent is you'll note something here. I was using top-level statements for my program kind of intentionally to hide away a lot of the ceremony, because normally you'd expect, namespace, public static void main, all the usual stuff you're used to. C#10, unindent the namespace, whatever. But here, you'll note I very intentionally did not put this in a namespace. So again, something you probably shouldn't do. However, things in C# do not actually need to be in namespaces. There is a top-level namespace in all of your assemblies called the global namespace, and you can put things there. So normally when it is resolving what class defined, it's going to be looking at stuff in my current namespace, stuff in my using. And then I've got this global thing up here where I can also find stuff in, which is where we have happened to place our string class, which is awesome. The other fun thing that's happening here is I went through and I added a couple implicit conversion operators. So in C# there is a whole breadth of operators that you can override on your given types, which is great. And in this case, it's going through and saying, okay, when I take in a string, and you'll note in this case, lowercase s string, this is the system string. When I take in that string, I'm going to give you back a new instance of this string. We're going to throw away the value. Who cares? This is intentionally bad code. And if we're going to go bad, we're going to just jump all the way off the deep end. And then, just for fun, when we convert back to a regular string, here's the value I want you to use. Now, a sane implementation might have held on to this value and done something useful with it or whatever. That's what a sane implementation would look like. This is not that. But then when we start to look back over at our datetime parse, it becomes a little more apparent what's happening. Is we read in this line, we get converted to a new class called capital S string. You can pretend like there's a fancy little conversion operator here, even though it's implicit and I can't spell. Typing's hard, right? That's what's implicitly there. And then there's also a subtle implicit one here, taking us right back to the system string, which is then hard coding that April 20th, 1987 date that we saw in our implicit operator, which is kind of fun. I was having way too much fun doing this. Okay, so let's go through and take a quick look then at the console, because we went through and we got a console read line and we got back to a capital S string. So if we continue on our merry way here. So console read line, naturally, and this should shock nobody, I overrode the console class. So that using system that you saw at the top was not for being able to get console. This using up here was so that I could get system.datetime. But if I had tacked that onto the front, that would have just spoiled the surprise and wouldn't have been nearly as fun. This console here is not system.console, despite what some might hope for. But you will be happy to know that the readline function I more or less left alone, in that it just forwards into system console readline. Writeline, on the other hand, we may have done something a little interesting with. So with writeline async, for those people really familiar with the base class library APIs, there is no writeline async on system.console. System console was written way back in ye olden days, long before async and await was part of the C# language. And so all of the console APIs are synchronous. You've got readline, writeline, and a whole bunch of writes and that kind of thing built onto it. But there is no writeline async. And more importantly, you'll note this little $sign that's sitting here in front of it. Now, typically, that would denote an interpolated string. Inside of C#, it lets you do things like what you would see down here, where you can then go through and put in your curly braces and populate parameters and that kind of thing. But it has a second usage that you can take advantage of as well. The compiler can actually go through, and I'm gonna drop this for just a moment. The compiler, when it sees that little $sign in front of your quote, it then gets to make a choice. And note, this is the compiler making a choice, so this has to be known at compile time. It can decide whether that little $sign in front of those quotes is going to be a string that you're going to format, or whether it's going to be what is called a formattable string. Now, the formattable string class is abstract. You could derive from it if you really wanted to. Please don't. That's a great way to get yourself into trouble. But more importantly, the type that it's going to return to you lets you go through and do some introspection on the string that got passed in. So normally, rather than doing a regular string format, you can actually get the format string and then the array of arguments that would normally go into that format string. My outline wants to turn off on me. So in this case, obviously, this was perfect. We're going to have some fun. So in the case where we don't have any arguments, once again, we're going to keep things simple. We're going to just go straight out to system.console, right? Feed the string out the door. It should shock nobody that the toString on formattable string returns the string itself. Who would have thunk, right? But then up here, we're going to do something a little more interesting. We're going to just go through and parse out the arguments a little bit and have a little bit of fun. So the first one, if it's a string, just output it, fine. If we happen to be on index 3, and it happens to be an int, we're going to call that month, just so that we can recall all the way back to the horrid use of it. And then we're going to go through and subtract 12 from it. So there was a fun little thing that actually happened back here. When you do random.next, the first parameter is inclusive, the second one is exclusive. So that's going to give us a random number between 1 and 11, which is important because, whoop, I need to double click, because we're going to subtract 12 from it. And if you have a random number from 1 to 11 and you subtract 12, that guarantees the number will be less than 0. Hold that thought. Finally, if it's any other int and we happen to be on index 4, we're just going to put in the little face emoji. I went looking for something fun. I don't count that as cheating character sets because that outputs exactly as you see there. So we're counting that, even though it's got some funny Unicodes. And everything else, we're just going to basically forward straight out. Ints go out, objects go out, everything just gets turned into it. And finally, we just take that formattable string and we say, okay, we've now done what we want to do with it. We'll actually now forward onto string format. This type of formattable string thing actually does have some practical uses that we've used in different projects. We can circle back to that a little bit later. So I want to go back here really quick, and if I can remember how to use VS Code and bring my terminal up. So let's see. Scroll up. So we'll just put that there where I can see it. So that gives us a small bit of an explanation for that last line of output. We've at least identified where the funky emoji face comes from. We know where the 34 years comes from, because that in our formattable string was just an int going back out. And we know that our date is basically being hard-coded at April 20th, 1987. Spoiler, that was 34 years ago. If you divide by 365 and ignore rounding problems, close enough. I don't intend to release this software. But I still have this 9 months problem that's floating around down here. That's now biting me. So how do we get a coffee cup in there? Because coffee was this morning, afternoons for Mountain Dew. So let's take a little look. So in C# 9, there was a lovely new feature that got added called module initializers. This is a feature that's existed in .NET for some time. So somewhere around the C# 4 days, ECMA 6 got released, and then Microsoft published an addendum spec to it, and module initializers were part of that addendum spec. So this has been around for a while. However, module initializers have typically been in the realm of people who do IL weaving and really bad manipulation of their assemblies. They're not usually something easily consumed. But with C# 9, they exposed it to where it's now an easy thing that you can add. You just have to declare a nice static method, decorate it with module initializer, and you're good to go. What this will do is before the first access of anything in your assembly, this module initializer gets to run. So somebody makes a static call, instantiates a type, whatever. Before the first access inside your assembly, this guy gets to execute. And in this case, we're going to go through and play with culture info. So something that oftentimes will bite people, and usually in the form of dealing with things like, I always love the French language because it's one of the ones where they swap the decimal separator and the thousand separator. So instead of being periods and commas, it's commas and periods, and that just, you can always tell when those types of parsing errors occur because somebody tried to do a double parse, didn't think about their culture info, and then got bit. Most methods that interact on that level, so any of your try-parse on the numeric types, string format, these things are culture sensitive by default, meaning they are going to run with the current culture of your system, which is great for UI display, horrible for just about everything else. Because your user changes their UI display, they now get to see dates in whatever their format they want to see it in. So for example, you could imagine like Great Britain, where we swap it goes day, month, year rather than month, day, year. Very easy to get those things backwards and turned around. But what we're doing here is something much more nefarious. So we decided what we're going to do is we are going to swap out some of the values on here. Now, before you panic and start having fun with culture info, it is worth noting you can only do so much damage here. Because ultimately, with this, the culture info is designed to represent a legit culture. There are a lot of checks bundled into this class to ensure that you don't do things like come up with a 3-day week. Everything inside of culture info has to reflect, we'll say, a sane culture, give or take a little bit. But that doesn't mean you can't do some really fun things with it. So for example, going through and swapping out the day names. Because naturally, going through and changing things up there and going with Latin seemed great. You could imagine if you wanted to reorder those and use the normal day names, that's going to be all kinds of fun. And then just because we could, the negative sign now becomes coffee cup. Because all of my negative numbers need to be a coffee cup. So that intentional random from 1 to 11 and then the subtraction of 12 was entirely around getting a negative sign in my output simply so that we could embed a coffee cup, which was awesome. I had fun with this. Okay, because that was too easy. Okay, so let's bounce back here because there's so much more fun we can have here. So we're gonna continue on our way up. So we kind of have already taken a look at the read line, the write line. Let's go up here into this read line. All right, we've already taken a look at console read line, and we know that it returns lowercase s string. Right? That's simple. And we know that on line 7, we hijack the implicit conversion operator to go through and go to a capital S string. But lowercase var is a contextual keyword in C#. So then the question becomes, what is the type of name on line 4? Well, see, the problem with var is it was added late to the language. And the language design team for C# abhors breaking changes. They absolutely abhor breaking changes. So when you see some of the decisions on new language features, oftentimes people will ask, well, why didn't you do it this way? Why didn't you do it that way? And a lot of those options are just off the table because that would be a breaking change. Last month's talk that Mark and I did on nullable reference types, you'll note that they intentionally made it an opt-in feature that you have to turn on because it changes your syntax and could cause breaking changes. They did not want to accidentally break somebody's existing code base without them, intentionally doing something. If you opt into a new feature, okay, well, you did something. You're now accepting the ramifications. So as it turns out, you can declare your own var class, which is totally exciting and awesome. So very similar to what we did with the capital S string, we can do with var, which I thought was just absolutely amazing. You'll also note this is where our first identity crisis comes from. So you'll remember when we ran the program, the very first time, that's the right click, we'll do the left click. Okay, I need to learn how to double click on tabs. It's very hard to do. So the very first time when it wrote out my name, it switched it from whatever got input to Bob, which is great, right? We read in a legit string, said implicit conversion into my own var class, and then went through and when it was output with the toString method, it happily went through and put in Bob. And Bob is on that toString implementation is just a string literal. No logic, no fanciness. This is the entire var class. toString outputs Bob most of the time. Because you'll note we had a second identity crisis down here, where we've done the exact same thing with the name parameter. We put it inside the little braces. We aren't doing anything fancy with formattable string on that. It should be fine, right? This should have fallen through our console write line, and we should have hit this object type on the way back out, because that's what var is. Now, people have written all kinds of things about var, when should you use it, when should you not use it, going back and forth. The general guidance for most people is usually only use var when the type is obvious or makes sense. The problem is that is a subjective analysis, and you could put two people in the same room and they could come to opposite conclusions. That's perfectly fine. If you happen to be on the opposite side of the fence where you say var nowhere, pro tip, you put one of these things in your global namespace, give it a private constructor, and no one can use var in your assembly anymore. And you have effectively disabled var for the entire application. Your coworkers may not like you that much. The other fun thing that this allows is if you combine it with C#9 target type new, that code now compiles and works. Because var is no longer the keyword, var is my type, target type new can infer the type from the left side of the equation, and that works. Will not work in most of your code bases, I hope. That should not compile in most people's code bases. If it does, I'm very, very sorry for giving your coworkers ideas. Okay, so that gets us through most of the stuff. And that at least gets us through the invocations that we see here. I think at this point, I have covered every method that I am directly invoking inside of here. What is still missing is that last line of output. So I'm going to just go through this here real quick. Open terminal. Because you'll note that very last line on that .NET run, we still have this troublesome little identity crisis of Joe. And Kevin is clearly not Joe. Bob is not Joe. And I can't scroll. I don't know where Joe is. Maybe he's still in a button factory somewhere. But there is another method that is subtly being invoked here. So we're going to go all the way back to my console write line method. Because you'll note, I had called out before that console doesn't have any asynchronous methods. So async and await was added in C#6. Don't quote me on that. And typically, when you have an async method, it returns a task. That should surprise no one. Or value task, or task of T. But it typically returns one of those. And you'll note on this method down here, I'm returning completed task. Now at this point, I'm hoping that most people are not surprised. I overrode task, because why not? Because if I can get myself between you and the BCL and have some fun, let's do it. So this is not system threading tasks, because you'll note the normal using statement that you would see at the top to get it is mysteriously absent. So if we come down here and take a quick look, you'll note I wrote my own task class. And I kept it simple. It was easy. You'll note class of task. There's a static for a completed task, just so that it looks like the real one, which rather than like caching the result, it's always going to instantiate a new one. Let's point that out again. The completed task, rather than caching its result, is always going to instantiate a new one. So with C#7, doing this from my head, I probably should have wrote those down, that lambda will get invoked every time the property is. Kelly.
So is that how you can get away with only setting the culture on the current thread?
So the question is that how I can get away with only setting the culture on the current thread? Not exactly. So
It's not actually async.
yeah, so it's not actually async, so there's not actually multiple threads at play, which is sort of helping that concept, because we'll get to it in a minute, but it should shock nobody. I'm not spinning threads with my task. Surprise, surprise. Typically, though, there's a difference between setting culture on threads and setting culture on tasks. So tasks are not threads. Tasks are units of work. They are designed to be lightweight so that you can create one of these and then kind of throw it over the fence to say, somebody go and do the work. By default, your task will typically be executed by something on the background worker queue. So that's for ye olde multi-threading days in C#. People used to use this a lot. What happened is async and await and task got built on top of that, and that will build up your tasks and run it. The thing, though, is typically when people are setting culture, they aren't setting it to, say, manipulate parsing or similar. You're almost always setting culture to manipulate UI. So desktop applications might set their culture simply so that they could like maybe give their users a picker of, hey, you know, we've added localization for Spanish, English, and French. Pick your favorite, right? You could rely on the Windows culture to feed into you, or you could let somebody override in your app, et cetera, et cetera, et cetera. So yes, it's a letting away with it, but there's also not multiple threads at play. It can be problematic if you need to set culture on all of the threads, because the background worker queue can spin threads up and turn them down at will. There's a fancy little hill climbing algorithm it does to, when the system's under load, of I need more threads, do more stuff, spin up, spin down. So that can be interesting if you try to muck with the culture of all of those threads. It's also why typically you should not be using system-threading.thread class directly for just about anything, because threads are really heavy. Every time you new up a thread, it's about a megabyte of memory. It's huge, because there's a lot of stuff that goes into having a thread that does work. So that was a very long answer to a very simple question. But you'll note this guy here, so, and to be clear, there is a big difference between this lambda here and an auto property that's directly instantiated. Both of these would work, but in this case, I would only instantiate a single task. And as you can see by that little instance counter, my goal is to count instances. So I want to instantiate it every single time. Now, why would we want to instantiate it every single time? And more importantly, you'll note that this task here is pretty simple. It has no base type other than system object, no interfaces, no anything. And yet, it's what's being returned from console write line, which ultimately can be awaited with the C# await keyword. No, you cannot manipulate the await keyword. Not easily. But I'm able to await my task. There's several areas in C# where this happens, but this is duck typing. So what you can await is anything that is awaitable. Well, that sounds great. I like awaiting awaitable stuff, but what makes something awaitable? And there are, whoop, you logged out. Pretty face, smile. Thank you. Not surprising, just like we were able to override the deconstruct method because it was something that was deconstructible, awaitable is anything that has a getAwaiter method on it. And naturally, we could have implemented this on the task class because I owned it, but that would have been no fun at all. So we did it as an extension method. But then, if you've got this getAwaiter method, what does it need to return? It needs to return something that's awaitable. And so we come down here, and you'll note that the stuff that you need to actually be awaitable is you need like an isCompleted property, an onCompleted method, which who needs that, and then this getResult thing. Once you do that, you are now an awaitable type. So if you have your own type that sort of simulates doing some work that should be some sort of awaitable-y thing, you can actually make it awaitable with extension methods. This was actually a very intentional change by the C# team because there was like old WCF libraries that had kind of this concept of, I want to do this asynchronous work and then come back when I'm done. Well, the problem is those old libraries were written well before async and await was a thought. And so they were like, well, we could do this instead, and now we can effectively shim that backwards functionality in without breaking those underlying types. That was a very useful thing to do. This is a horrendous abuse of it, which the only response is whack. So you'll note, though, what we ended up doing is that instance count, I just count with. And when we come into here, we take that instance count and we wait until the instance count gets to 2. This is highly specific to my application, as most of this stuff is. I hard-coded everything. But when instance count comes to 2, we have our second identity crisis, and we erase
Kevin.
Bob.
Kevin, sorry, we had a question from the chat. They just asked unsafe.
Unsafe?
Yeah, following up with what you said, it sounds
Hold
like.
on, we're getting there.
Okay.
Yes, we are getting there in just a moment. So way back in the very first thing that we noticed, in my directory build props, and I kind of just completely ignored it as I was talking through it, you'll note that I added in a build property to turn on unsafe blocks. This is a feature of C# that's been around for a very long time, but it's one that you have to turn on. And it's intentional that you have to turn it on, because once you turn on unsafe code blocks in C#, you can do some nasty, nasty stuff. You can have a lot of really cool performance stuff, because now you can manipulate pointers and other fun items. But it does mean that you have to opt into it, and then more importantly, C# is still a garbage collected language. You have to do battle with the fact that the garbage collector likes to move objects around in memory. So It's very powerful. Some people can get some really great performance out of it. A lot of improvements in Net 5 and Net 6 have been around making it so you don't need to do this, and you can do it in a managed and a safe way rather than being horrendously abusive like what we're about to do. So down here, you'll note when I'm getting the result back out, and I'm going to kind of take this in the reverse thing. The question from the chat about unsafe, yes, we are going to go into unsafe context. So the unsafe keyword can be applied either in a code block, you can put it on a method directly if you want the entire contents of the method to be treated as unsafe. But once you're inside of the unsafe block, you can now do some really fun things, like get a char pointer to a string. Now, strings in C# are mostly immutable. They're immutable until you get a hold of their pointer and start mutating them, which is awesome. So you'll note here, we go through and we say, okay, my old name is Bob, my new name is here, and I'm just going to iterate through these things, and I'm going to just replace the characters B-O-B with J-O-E. Now, something I subtly abused is that I picked two names that were of equal length. That is important, because when you are manipulating pointers, you can walk off the end of your array into who knows where and have all kinds of nasty things happening. All of the pain that comes from C and C++ that let you do this by default, you can opt back into that and go back to the dark ages-ish, give or take. Hopefully no one throws anything at me. And you can do it once again in C#, which is great. But then the question is, if we remember, back on our var class, our toString method is returning a string literal. We are attempting to mutate a string literal that is off in another class. And clearly it works. So you'll note up here on line 25, there is a small call here where I am intentionally calling new var toString and just throwing the return value away. Not 100% strictly necessary given how programmed CS was, but when I was building this, I was moving code around and this prevented me from getting into trouble. I'll explain. In C#, if you have a bunch of string literals, you can imagine that if I was writing a Bob library, I might use the string Bob a lot. Now, if inside of the assembly, the compiler said, I'm going to declare enough space for all of these Bob instances everywhere, that would start to get large. That's not useful. So as an optimization, what we can do is what's called string interning. So it will end up keeping a nice dictionary of all of our strings that it can use, and then just go ahead and reuse those strings each time. So when I pull out this string here and intentionally invoke that literal, and this string down here, what I'm doing is ensuring that those strings have been properly initialized and stored inside of the string intern table. So that when I get a pointer to it here, it's the same pointer as the literal back in the toString method. The other reason for doing that is C# in the code, when it goes and executes, depending on how compiler options and whatnot, the jitter, the just-in-time compiler, when you start up your app, all of your code isn't necessarily compiled to machine code right away. That would be a long process, and your startup time would be horrible. What the jitter does instead is it goes through and just in time goes through and will convert your IL into machine code when it needs it. So in this case, I am invoking it specifically to make sure that that thing has been jitted before I go after it. Because if not, I might end up replacing one string, and then that other string literal is now seen as a different string, not in my string intern table, and well, Bob doesn't get erased. And that's just no fun, because we all like Joe better. So the question is, you can't debug that, can you? Well, so here's the problem with debugging. And anybody who wants to go back and watch me struggle on this, you can see on my Twitch stream or the YouTube recording, when I was initially writing this, that bit me left and right. Because the problem is with the debugger, when you inspect that value, guess what happens? It gets interned. So you have this problem when you're trying to debug this. You can change the behavior by looking at the value and then get very confused for about 35-ish minutes while you go, what the heck? Why does this work when I'm debugging but not otherwise? Which is not a real great experience, but more importantly, you shouldn't be doing this in the first place. However, when this is working, at the end of your unsafe block, if you go through and inspect these two things, you should see both of those things changed. So once it's done being its abuse of self and erasing those things, you can then go back and look at it. If you look at it first, though, you can change the order of when things get interned or potentially move things around. The other thing to call out is this fixed keyword here in C#. Whenever you're inside of a unsafe block, this tells the garbage collector, give me a pointer. By the way, I'm using this pointer. Don't move it. Fix this guy in place, nail its feet to the floor. That way, as I'm manipulating this, the garbage collector doesn't come through, run, and do something horrible like pick the string up and put it somewhere else. So that's just one of the kind of things you have to keep track of inside of C# when doing unsafe blocks, because things can bite you all over the place. Same thing as pinning, yes, absolutely. Absolutely. So with that, we now have an explanation for how our entire program works. And that's it. So feel free to open this up for questions. One question I actually have for all of you, and if people online want to chime in, if this type of content is useful for people, please let me know. I only used about half my material writing this and have more, even worse things that are possible in C#, especially if we start deleting some of those mean rules at the beginning. You can do some really awesome stuff. Kelly.
Why is the language service highlighting
Why is the language service highlighting
please in your?
what? Oh, please and your? Because I have not actually installed OmniSharp. So one of the so there's a reason I'm giving this talk in VS Code and not Visual Studio, because unfortunately in Visual Studio, when you load up that CS proj, Visual Studio very helpfully finds the directory build props and shows you that in your Solution Explorer. Not handy. And then more importantly, it starts to give, in Visual Studio, the highlighting of, say, this var keyword. It quickly figures out that this is not the var keyword, turns off the default keyword coloring of blue and makes it green. And I was doing a talk on how to do things poorly, so I went with the thing that would make it weird color. So that's the reason, is I very intentionally have not installed OmniSharp. It's also the reason for that obnoxious pop-up in the bottom right corner where VS Code really wants to install OmniSharp for me. I appreciate it, and most of the time when you're writing C#, that is a good thing to have, but it is not useful when you're trying to be obtuse. Any other questions? Or anyone online? Again, I'm always happy. If people want to see this code, it is out on my GitHub. You are, like I said, you are welcome to look at it. I would encourage you to not use it for anything. Absolutely anything. In fact, oh, the GitHub deep storage, it might be, I hope not. This is one of those things that I'm actually okay if it dies. It was fun to build and write, and it was actually entertaining to see how tight I could get it, and see how many lines of WAT I could pull through and do in 14 lines of code. But initially I had this last write line on one line, but that was just too long. It ended up wrapping funny. Sorry, that right line. Perfect. Nicole, any questions from anyone online? I'd like to thank you all for not bringing anything to throw at me.
Question.
Brent.
So from a security perspective, you open this, say you have this hosted in GitHub or something.
Yep.
Someone downloads it, they fire it up in Visual Studio.
Mm-hmm.
What's going to happen? Are they going to be prompted with a warning saying, hey, this says potentially malicious code or unsafe code, or?
Yeah, so the question being around the security, somewhat built into the IDE, if somebody goes and downloads this code and goes to execute it, will there be some sort of prompts built into it? So the answer is it depends a little bit. So latest versions of VS Code and Visual Studio, depending on how you download your repository, will actually prompt you to say, do you trust the authors? That has nothing to do with the contents of the code and everything to do with the fact that it's seen a new download of code and trying to guard you from that. So it's not really tied to what's in the code base. So you will potentially see that security pop up. But as far as like the compiler and whatnot is concerned on here, there are no security vulnerabilities in this code, which is terrifyingly awesome because it's just really bad code. Now, admittedly, what would likely cause the security vulnerability is anyone attempting to use this library, because a reasonable developer might go through and do something that seems reasonable. And in this library is absolutely horrendous. John Skeet gave a talk with some of the similar kind of topics of this. And around that formattable string bit that he did, he had actually done a demonstration with SQL. And his comment was, it was actually reasonable code that he had written because he took that formattable string, took the parameters, and built up an actual SQL string with the parameters to prevent SQL injection. His one comment was, the problem with that is even though that code was technically fine, anyone looking at that code might go, that's how you build up SQL strings. No, bad. And then somebody takes that information and then goes and does something potentially horrendous with it and adds in SQL injection. His code obviously mutated the formattable string into something normal and useful, but the downstream effects of that can be problematic. And I think most, if not all, of the features in here actually do serve a purpose, a legitimate purpose to be used. Now, maybe not the target type new with var, that one might just be abusive, but most of them serve a legitimate purpose that you could actually find a use case for, but they do feel a little bit like that magic trick. And if you end up with that kind of magic trick, you have to always take into account who's going to be using this, and is it going to be oh, that's cool, it just works the way I want, or dear heavens, what is going on, right? If you're in the latter case, you might consider that your magic is doing more harm than good, because you can cause bugs inadvertently even if you don't write them. You could set somebody up to effectively walk off a cliff. And we would prefer guide rails.
You could take all of the stuff except for program CS, ship it as a DLL in a NuGet package, put that in directory.build.rems as the root of the machine, and spoil every project.
So yeah, Kelly's comment is you could take everything underneath my bad stuff, put a directory build props on it, ship that as a NuGet package, or put it at the root of somebody's drive, and they would have a very, very bad day. It's actually worse than that. Inside of NuGet packages, if you name your files appropriately, you can actually have a NuGet package that contains a targets and a props file, and those get automatically loaded and included with the project, which is great. Again, useful case. There are plenty of libraries that leverage that to set things up appropriately and get their systems kind of tied into your build pipeline. But it means a NuGet package can get tied into your build pipeline. And in theory, if that includes this kind of code, that could be not useful for some people.
Potentially very damaging.
Or potentially very damaging. Yeah, you could have some code that goes really haywire.
It ships your source code to somewhere else.
Yeah, picks up your source code, uploads it somewhere else, does something
So there's
horrendous.
Supply chain concerns this day and age.
Yeah.
It's very important to make sure you secure your build systems.
Yeah, so the comment being around securing build systems and supply chain attacks. We haven't seen any major supply chain attacks this year, right? SolarWinds. It's only October. We've only had a few major vulnerabilities of things flowing through. What else? Any other questions? Is this useful to anybody? Entertaining. Again, this bad code, but hopefully at the end, we have a little bit better understanding of how the C# compiler works and all kinds of other fun things that we can do with it. I will say this deconstruction trick does actually lend itself really well when you want to for each over something and have two values that you get in your for each. Because normally people always think I'm going to for each and I'm just going to get the one current item, but you can actually use deconstruction as part of your for each to get two items. So you can imagine iterating over a dictionary rather than getting that key value pair item that everybody's used to seeing. Deconstruct that, and now I've got var paren key value as I'm iterating, and it saves me a call and makes the code look cleaner and behaves the way I expect. It doesn't lead me into the pit of despair, which I believe is the conference room back corner for the Princess Bride fans. Cool. Anything else? Thank you everyone for coming, and we'll see everyone next month.